Good afternoon, geometry students. Today's topic will be slope, or as they say in France, slope. The equation for slope is going to be y2 minus y1 over x2 minus x1. It does matter which y and which x go in what place. So let's go ahead and start with an example. We'll go ahead, our first example here from the notes, if you're on the PDF version of this, will be what is the slope between the point -2, 1 and 3, 7. Now the question you got to ask yourself is, do I know what the x's are? And you do. We're going to start here with the x's and the y's, our y values being 1 and 7. And like I said earlier, order matters here. So it doesn't matter if you start from your first point or from your second point. You just have to make sure that in both the numerator and the denominator you do the same thing. So let's go ahead and start in the second point here. And we're going to start with our y value. So we're going to take y2, which is 7, minus y1, which is 1. And we're going to divide by x2. Well, x2 goes with y2. So x2 would be 3, and x1 would be -2. Now remember, you're subtracting, and you're subtracting a -2. So when we subtract a negative, we chop chop, and we get 7 minus 1, which is 6, and 3 minus a -2, which is the same as 5. And that is the slope of our first example. Number 2, let's start with another one here. Our first point is 7, -2. Hi, Nicole. That's okay. You're making a cameo on my one of my videos.
You need a sign.
I do need a sign. Okay, here are our second 2 points, 7, -2, and 7, -5. I'm going to start now in the first point, so we can call this y2. It doesn't matter which direction you go, and I subtract my y1 and divide by x2 minus x1. Okay, as we do this simple manipulation algebraically, instead of minus a negative, I'm just going to add -2 plus 5 is 3, and 7 minus 7 is 0. Now this brings up an interesting point. Hopefully you're realizing you can never divide by 0. Okay, you're going to get an error on your calculator. Slopes come in one of multiple possible types here. A positive slope, like our answer to the first example. Negative slope, undefined slope, and a slope of 0. Now, the example we just did in number 2 is an example of an undefined slope. You cannot divide by 0, therefore that slope is undefined. Let's think about this for a second graphically. Graphically, a positive slope goes up from left to right. That's what the graph would look like of that line. Negatively, from left to right, it will go downward. Undefined slope is a slope that is vertical, and a 0 slope is a horizontally flat line. Continuing on with this idea of slope, y2 minus y1 over x2 minus x1. Here's an interesting example that you'll also see in your notes. We'll call this example 3 for right now. Let's say that we know one of our points is -4, -2. That'll be in the bottom left quadrant. And another point we know is 4, but we don't know our y value. But let's say I tell you that you do know the slope is 1/2. So where should we go from here? Well, let's do this. Let's write out the equation y2 minus y1 over x2 minus x1 and that equals our slope. Okay, let's continue from here. Now, let's call this value here y2. We'll call this value here y1. And let's put those in the numerator of our equation. So if we do not know y2, but we do know y1 is negative 2, and we know that 4 is our x2 and negative 4 is our x1, we can plug those in as is. Do we know the slope, as we've said here? Yes, we do. It's 1/2. So now let's do a little simplification. Let's take this work over here to the left. So we have y2 minus a negative 2, which would just be y2 plus 2. In the denominator, we have 4 minus a negative 4. Well, that's the same as 4 plus 4, which is 8. Now it's simple algebra. Now to solve this problem, similar to what we did yesterday, we're going to multiply both sides by the denominator. And what we get is y2, let me clean that up a little bit, y2 plus 2, these 8's go away, equals 1/2 times 8. 1/2 of 8 is 4. So now we simply subtract 2 from both sides of this equation, and we find that y2 equals 2. Now the solution to our answer here is that the second point is 4, 2. Great. Hey folks, here we are again talking about slope. Now I want to look at this concept graphically. What you'll notice here in the numerator of our slope formula is that y is changing. And really what that means is that this little triangle, that's the Greek letter delta, and what that means is change in y. And then again, when we look at x is changing as well. It's going from one x value to another. That's called the change in x. Another way that we can express this is the rise, or how much the graph goes up or down, divided by the run, how much or how far the graph goes left and right. So if we look at the graph here on this grid, we'll notice from this point here, which would be 0, -3, it moves to this point here, which is 4, 0. Okay, so let's determine how much it rises and how much it runs. So let's start at the point on the left. We know by graphically that this slope better be positive. If it's not, then you, I don't know, you might want to eat your Flintstone vitamins again and double your dose. But here we go. So let's check it out. As we go from this point here at 0, -3, the rise is how much it goes up. How much did it go up? It went up 3 units. Now the run is how many units we now travel from left to right, or right to left, depending on the situation. The run in this case was a positive 4 units. To the right is positive, to the left is negative. Up is positive, down is negative. So from 0, -3, we traveled up 3 units and right 4 units. And that is our slope. You guys, I'm unfortunately in South Dakota right now, so hopefully you are getting something from these videos and can complete your homework. Just a reminder, on Monday you will have a quiz. Okay, Monday we will have a quiz. Hold on, wait, let me check my schedule. Yes, Monday, quiz. All right, have fun, have a great weekend. We'll see you on Monday. Bye.